Welcome to TTP-Based Hunting, Step 4, Filtering. In this module, we'll review the overall methodology and purpose of these courses, in addition to the objectives of this module and how it fits into the overall method. We'll talk about why filtering matters and what would cause us to revisit what we filter out and what we leave in. This module is organized around the three dimensions of time, terrain, and behavior. Finally, we'll wrap up with some examples and a scenario. We're at the pivot point in this methodology V. In this step, we will filter the broad set of TTPs, hypotheses, and data collection requirements developed by the community to focus on the ones that are applicable to our networks, systems, missions, and scenarios. This series of courses is intended to provide the foundational knowledge needed to begin TTP-based hunting in your environment. This module should prepare you to determine which TTPs, analytics, and data collection requirements are appropriate for your environment. Just like the other modules, you should be familiar with Windows and networking fundamentals, have some experience with an analytic platform like Splunk or Elk, and be familiar with ATT&CK. To put these ideas into practice, you'll need an environment you can instrument with an analytic platform. Steps 1 through 3 of this methodology are being done by many people in the global cybersecurity community. For example, ATT&CK is periodically updated with new adversary tactics, techniques, and procedures. Security researchers like Roberto Rodriguez and Olaf Hartong frequently publish new analytic approaches and data collection recommendations. In addition to these community efforts, you and your team are likely doing your own research and investigation to develop your own hypotheses and instrumentation ideas. It's in this step of the methodology that we're going to filter down all of that input to what is applicable to our particular network. We're going to pivot from those community efforts and customize things based on what we need for our environment, our technologies, and our missions. So let's dive into filtering. Why and how? Let's start with the why. We're all dealing with limited resources. Time, money, bandwidth, storage, processing. Given those limited resources, it makes good sense to think through the technologies you're using and the scenarios you're concerned about before trying to test and tune every analytic anyone has ever developed, or to investigate and implement every data collection plan. To start, we'll filter out any of those community contributions that don't apply to us. In time, things will change, and we should periodically check back in on our filtering decisions and update them if needed. Adversaries are constantly seeking new ways to accomplish their goals and evade detection. We need to be sure we're keeping up. Our own systems are also changing frequently. As functionality, software, and devices are added and updated, we need to make sure we're including the associated analytics and data collection plans. And keep in mind that community knowledge, best practices, and ideas are also frequently being updated in response to adversary evolution, technology change, and new discoveries of existing adversaries and technology. We need to stay aware of those changes and keep our filtering up to date to ensure we continue to include relevant analytics and monitoring. It might help to think about filtering in each of these three dimensions of time, terrain, and behavior. Generally, we don't want to filter based on time for a few reasons. We want to collect data when there is no malicious activity, so we're familiar with what benign activities might be generating false positives. Collecting at all times also helps us gain context and uncover the full scope of an adversary operation. Continuous collection will also mitigate the risk of an adversary covering their own tracks by erasing logs before they're collected. Finally, we usually don't have advanced warning of when an adversary will act, so we need to collect continuously to ensure we're collecting when the malicious activity occurs. A possible exception is if there's threat intelligence that indicates an imminent threat or an upcoming event that increases the risk of an attack through increased exposure or increased adversary motivation or increased impact if an attack were to occur. Under these circumstances, you might be willing to surge in defensive measures beyond what would be acceptable for normal operations. For example, you might be willing to shut off certain accesses or deactivate accounts, increase logging and analysis, or increase analyst staffing temporarily. In many cases, it will be appropriate to filter based on terrain. Which technologies are in your terrain? If you don't use industrial control systems, then techniques associated with ICS are not likely to be relevant for you, and you can filter them out, along with their hypotheses, analytics, and data collection requirements. Just keep in mind that you might have more technologies in your environment than you first think. For example, even if you have a relatively small network with Windows hosts, your routers, switches, servers, and firewalls might be running Linux or Cisco. Your team might bring in their own mobile devices or laptops, which might not run Windows. There might be IoT devices in your environment. You might be hosting things in a cloud. So be sure to think it through. Also, note the versions and configurations of your software, as that can influence which techniques or sub-techniques apply to you. Once you've identified the technologies in your terrain, be sure to include the relevant techniques, hypotheses, analytics, and data collection requirements associated with those technologies and configurations. As you filter down the analytics and data collection requirements, consider if your particular setup would require modifications to what the community has developed without knowledge of your configuration. Are there techniques which are likely to cause a lot of false alarms due to something unusual with your environment? Also, think through the critical business functions or missions that occur in your environment. Does your terrain's configuration and mapping to your operations make certain devices more likely to be targeted? Would certain locations in your network have better visibility than others? Are there separate enclaves within your environment that might need special monitoring? Document the failure scenarios or unacceptable losses for your environment and trace back from those to find likely attack paths and identify key terrain to monitor or protect. Finally, consider how you might filter based on the behavior dimension. Are there specific TTPs of greater concern due to existing threat intelligence or detection of malicious activity? Keep in mind that some analytics are excellent for getting the initial detection of malicious activity, but you might need others to flesh out the context of that activity and help distinguish malicious from benign actions, or to uncover the full scope of an adversary's campaign. And finally, it might help to prioritize including TTPs that are strongly linked to the operational impacts you're most concerned about. Let's walk through an example scenario, and then you can try this yourself with an exercise. For our example scenario, imagine an e-commerce site. Users browse the site across the internet from various devices outside the scope of your control or visibility. Financial transactions are handled by a third-party platform outside of your environment. Browsing and purchase requests, along with help desk communications, pass through a firewall into your enterprise where they are routed to the server or call center as needed. Call center employees use Windows desktops and might bring in their own personal mobile devices. Web developers also work within this enclave to keep the site updated. The web server is running Linux and connects to a data repository, which is also accessed by a shipping management system to handle deliveries from the warehouse. Requests for new manufacturing from the factory go out through the firewall. Now, the e-commerce site plans to launch a new product soon. Think through the dimensions of time, terrain, and behavior to consider what you would want to include or exclude from the community repositories of TTPs, analytics, and data collection requirements for this scenario. Pause the video and give yourself a few minutes to think this through. Welcome back. What'd you come up with? There are many possibilities, but here are a few things we considered for this scenario. In the time dimension, the planned upcoming release of a new product indicates a period of increased risk. The launch is likely to create new exposure through marketing, trade shows, and possibly new business partnerships. The launch also causes heightened concern about ensuring smooth business operations as new customers engage and initial product reviews are written. We might be willing to spend more resources during that time period to monitor our systems, and we should think through any new connections we might be making with new customers or new businesses and check how that affects which TTPs might be important during that time. For terrain, most of our workstations are Windows, but we also need to include Linux techniques for infrastructure systems. How will we handle employees bringing in their own devices? Should we restrict that by policy? Or maybe we should include mobile TTPs in our hunting approach. Regarding behavior, a compromise to our internet-facing websites would have big mission impact. So we need to include any TTPs associated with tampering that kind of information. We also need to be sure we include lateral movement techniques as a priority, given the easy access between call center employees, developers, and our server and database. Now, there are many other good things to consider in this scenario, and these are meant as examples, not the only correct answers. So for your exercise, consider a different scenario. In this case, the environment is that of an energy company. Behind an internet-connected firewall, a Windows environment hosts operators, help desk employees, and developers. The Windows environment can communicate through a set of devices to industrial control systems associated with the power generation equipment. In addition, technicians are frequently working on the equipment in the field using mobile devices to troubleshoot, update software, and communicate with the operators and developers. So, given this scenario, what should the power company consider in terms of time, terrain, and behavior when filtering down the TTPs, analytics, and data collection recommendations from the broader community? Pause the video and give this some thought. Welcome back. By completing step 4, we now have a filtered down set of TTPs, hypotheses, analytics, and data collection requirements, which are relevant to our environment and operations. In the next steps, we'll start implementing, testing, tuning, and using these hunting ideas in our own systems. Step 4 is a pivoting step from the more abstract research and generic work in steps 1 through 3 and into the more concrete implementation steps 5 through 7. Here's a review of the TTP hunting V. We've gone through steps 1, 2, 3, and 4. And steps 1 through 3 can be done by people around the world. And cybersecurity researchers are working 1 through 3 all the time. And you can too. It's really in step 4 where we need to get specific about the environment in which we will hunt. We need to understand the time, train, and behavior aspects of that environment that will influence which elements of steps 1, 2, and 3 we need to use for our particular environment.